Hello everyone, back to the CGPA booster class of application of derivatives. So today is your last revision class of unit 3 part 2. So what will we start? So what are the topics we are left with? So we are left with Maclaurin series expansion, Taylor's theorem, then indeterminate forms and the way to solve it, that is L'Hopital's rule.
Hello, hello,
So sorry for the technical glitch. So welcome back to our application of derivatives. This is the last class of revision of CGPA booster for MTH165. So what are the topics we will be covering in the second part? Maclaurin. So we will be covering Maclaurin series expansion, Taylor's theorem. Then we will do the what are the indeterminate forms and the way to solve an indeterminate form. That is the method is called L'Hopital's rule. And after that we will be seeing two application of derivatives, two more, that is increasing and decreasing function and maxima and minima. And with this our syllabus will be completed and we will be ready for talking in the exam. So guys, let's start with Maclaurin's. I'm writing it short. Maclaurin's series expansion, MSE. So what is a Maclaurin series expansion? Suppose if a function fx of the variable x such that it can be expanded in the ascending power of x, then expansion can be differentiated and expansion can be differentiated any number of times, then it is expressed as the following. Then f of x will be shown as f of 0, then x by 1 factorial f dash 0 plus x square by 2 factorial f double dash 0 plus x cube by 3 factorial f triple dash. Now what are these dash? These are the number of times it is the function fx is differentiated. When there is a single dash f dash, then it's differentiated single time. F double dash means double differentiated. So you're understanding how is it. So it will be continued like this, and it will continue till a point where it will be x to the power n, as evident from the particular terms where n is 1 2 3, 0 1 2 3. If being differentiated n times 0 and continued. So why we do this Maclaurin series expansion and all? In our previous classes, while you were in 11 and 12, you must have studied those sin x, cos x, vagera vagera, right? The expansion of sin x, cos x. So you, at that point of time, we used to memorize them, right? We can also find out that Taylor series. Okay, so I'll show you after the after this. So how to do that? Let's see. Okay, finding sin x. Okay, so let's let me show you how we find the series of sin x. Okay, this another thing. This f dash, you can also write it as, okay, let me show it the red ink, or else it will be like a cram. This f dash you can show as y1 also, f double dash y2. Henceforth, x being differentiated n number of times, you can show as yn. So now let me take a blue ink. I love it, blue. So let's find out the series of sin x using this theorem. First of all, let assume y to be sin x, not assume fx is equal to sin x, that is equal to y. And so y of 0 will be what? 0, because sin 0 is 0, no doubt, right? Okay, this you can take as y0. Done. So now, when we will differentiate this only one time, y1 is equal to cos x. Obviously, differentiating sin x, you always get cos x. When we will differentiate, okay, this will be 1. I written 1 only, okay. y2, differentiate second time. What will be the differentiation of cos x? It will be definitely minus sin x, right? Then when we will differentiate it for the third time, what will it be? Minus will be as it is, sin x will change to cos x, right? Now, let's put the values here. Y of 0 is 0. Then y10 will be is equal to what? Value of cos 0? Obviously, it's 1. Then what is the value of y20? It's 0. Then value of y30, it will be minus 1. Okay. So now, can you find a similarity? What we have to do? Can anyone assume? Obviously, whatever the values we have calculated from here, we will just put this value into this parent equation and check what it comes out to be. So we just have to put the value y of 0 here, y10 here, everything, and see what it comes out. So if I can clear the screen. Let me just clear the screen. So just remember what values we have got, or rather take first take a screenshot of this page. 5, 4, 3, 2, 1. I hope this time was enough to get the screenshot. If not, take it. Okay, now let's get to the second page. Okay, so now what we have to do is that we have to put the values of sin x. Wait a second, let me take again that blue ink. I love it. Sin x, because we have taken y is equal to sin x, and we will put the values in the parent equation. So value of y0 will be 0 plus value of y1, it will be x by 1 factorial y2 again 0, then y3. So we used to memorize it like this, that all the odd terms we will consider, but now you are getting directly the proof of it. It will be alternately plus and minus, and it will, and all of them will be odd terms like x cube. I mean 3 factorial, like these digits will be, we used to memorize it like this now. So now this time, if you ever forget in the exam, you don't have to like mug it up. Now you're having the proof, just put the value and get it. If, let me see, I can get another. Okay, let's see example of e to the power x. We also used to memorize another equation of e to the power x, right? Let's see what it comes out to be this time. Okay, so let's consider y to be e to the power x. Got it? So y1 will be again e to the power x. We all know, no matter how many times you differentiate or integrate e to the power x, it will be same. It will come e to the power x only. So just I'm writing it directly, y to the power n e to the power x, right? Now value of y1, okay, value of y0, sorry, it will be 1. Now when anything to the power 0 is always 1, so no matter, and the value is always e to the power x, so no matter how many times you put 0, it will be 1 only. So I hope you will just put the value there, and you know what will it come out to be. 1 plus x by 1 factorial plus x squared by 2 factorial plus x cubed by 3 factorial. If you want, let me write it here. E to the power x, since y0, y10, y20, y30 all will come out to be 1, and y1, y2, y3 all are e to the power x. So just without wasting time, let's put the value itself. 1 plus x by 1 factorial plus x squared by 2 factorial, and it will go on and on and on and on. Okay, so this was the Maclaurin series expansion, and now you can just formulate any series of your choice. Now let's go to our next topic without wasting a single time, and that's Taylor theorem, or Taylor series expansion, whatever it is. I'm just writing it here. Okay, so if a plus x is a function, be a function of the variable of the variable x such that it can be expanded in ascending powers of h, and this expansion be differentiable any number of times, then x plus h will be is equal to f of a plus h f dash a plus h square by 2 factorial f double dash a plus, it's going on. I hope you are getting what is it come, h to the power n by n factorial y n a. So let's prove this now. How is it coming? And let's see this. And after that, I will show you the special case and how to get the Maclaurin theorem out of here. That's it. Okay. Let's see the proof of it. Okay. So as we have seen, the value of f of a plus h plus h1 h square a2 up to it will be h to the power n and a n. Then let's differentiate it once. So what will it be? A0 is a constant, so it will be 0. Then a1 value of h will be, differentiation of h will be 1. So then 2ah a2 and this will go on and on up to differentiation of you know n h n minus 1 a n. Why am I differentiating every step? You will get to know it very soon. The reason being, we will get a formation of a factorial. you know we will get a formula out of here by making some modification, and you can get the equation directly. Then again, a1 is a constant, so this time 2h2 and a definition of h is 1. So I am not writing each and every term. It will be n into n minus 1 h n minus 2. Obviously n minus 1, another minus 1 will be there, and a n. This will continue. Suppose if we even make it another differentiate another time, let's see what it comes in. So all will be differentiated as per the formulas, and the last term will be like n minus 1 n minus 2. So it's like kind of, it's coming in terms of factorials, right? N minus 3 this time, and a n. Well, this will also change, a n minus 1, this will be n minus 2 and all. So anyways, let it change. So what to do now? Just remember this equation and you can take a screenshot of it, and let's go to the next step, and the next step would be put h is equal to 0. Why? What will we get on putting h is equal to 0? So let's see, f of a will be a naught, f dash a will be a1, f double dash a a2, okay, 2a2, and f triple dash a we got 6a3. From here, value of a2 we got as f double dash a by 2, which we can also write as f double dash a 2 factorial, and in this case we will get f triple dash a by 6, and 6 is equal to 3 factorial. What is 3 factorial? 3 into 2 into 1, and that will result to 6. So highlighting these values, we got this, and now okay, and now if it is yna, then the value will be n factorial an and an will be is equal to yna by n factorial. So now what our job is to put these values in the equation 1 that we have seen in first time, that is f of x plus h is equal to f of a plus h into f dash a plus h squared by 2 factorial f dash double dash a. Okay, so now you have to put the value there, and what will you get is the resultant will be f of a plus h is equal to a naught, sorry, a 0 plus h a1 plus h squared by 2 factorial f double dash, or you can write as y2a, and this will go on. So this is a Taylor's theorem, and we have derived it. Now there is a special case of Taylor's theorem. Let me show the special case. So what is the special case? Let a plus h is equal to x and h is equal to x minus a. So f of x will be f of a plus x minus a one factorial f dash a plus x minus a whole square by 2 factorial f double dash a. So why have I taken this special case? Now see, put a is equal to 0. Just do it yourself. Pause the video and just put 0 and tell in the comment section what are you all getting. If you put 0, you don't have to calculate or find out the result. You just have to put 0 in place of a and write and name what will you get it. Okay, pause my video. I'll be writing, but you have to pause my video and do it of your own. So f of x will be is equal to f of 0 plus x by 1 factorial. Shit. I can write as y1a, or it's too hectic to keep those dashes. Then x square by 2 factorial, and it will be y to a, and it is like last term will be up, nth term will be not last term, xn by n factorial. So I hope you have paused the video and did it yourself. And now I would expect again to pause and name what equation is this. Yes, I hope you all have guessed it correct. It's Maclaurin's series expansion. And henceforth, we have derived Maclaurin's expansion in two ways. In once we have done it before. Secondly, we have derived it from Taylor's theorem also, right? So let's just see a question. Okay. Okay, no question. Okay, we have done the question only. Well, you guys have to put values here and it will be done. So we have to move on to the next topic because today we will be completing our syllabus, and that is indeterminate forms. Shit. Let me find out the text here. Okay, no. Now we'll be doing indeterminate forms. So what are indeterminate forms? Indeterminate forms are not like something meaningless or what. There are basically 7 forms of indeterminate forms, and they're not completely meaningless because the thing is they you often get them in limits and you might not get any clue of the result how to do it. Okay, so let's go ahead. So there are 7 forms of indeterminate form, 7 forms basically. Okay, so what are those 7 forms? There is 0 by 0, infinity by infinity, 0 by infinity, infinity by 0. Okay, infinity minus infinity, 0 minus 0. All these are indeterminate forms. So let's take like a limit x tends to a, f of x by phi x. This will be equal to x by a, x tends to a, not x by a, f of x. So we are just, as per the properties of limits, we are applying limit on numerator and denominator. We have learned this in limit. You must have learned this in classes of limits. Okay. So we will do this by Taylor series theorem itself. How? We know f of a is equal to q of a will be 0. So by Taylor series theorem, let me write it here. Limit. Okay, let me take a fresh page, or else it will be too. Hmm. We'll put limit x tends to a f of x by phi x which gives limit x tends to a f of a. Well, we are doing this for the numerator, and it will be again x minus a. We'll just apply the Taylor's theorem here, the general one, not the special case, because that is because then it will come to be result to be as Maclaurin's theorem or something else. We are applying the general equation here, general theorem. 2 factorial f dash a. Well, it will go on. So writing all of them is a waste of time. So now below same, just in place of f it will be phi plus x minus a by phi a. And it will be on and on. So what are we getting from here? This so after applying f of a, all the terms will become 0, and we will get only a single term, that is f dash a divided by phi dash a. So what are we getting in when it is 0 by 0, infinity by infinity? Basically the types of numericals will get over this only when they will be of this form. Na, you just have to differentiate the numerator and the denominator until and unless this form you are not getting, and that way you can solve the limits. You just have to differentiate up and down. Okay, like if it is sin x, wait, limit x tends to 0. Well, wait a second. X by sin x, suppose limit x tends to 0. So x, so it is the form of 0 by 0, right? Because x is 0, then sin 0 is also 0. So just differentiate it, upar niche, okay, with respect to x. 1 by cos x. Now apply limits. What will it be? Answer will be 1. Simple, right? Because cos 0 is 1, and 1 by 1 1, job done. That's how you will do it. So simple. So let's go ahead with our next two type of things are left. We will cover up it by now only, and that is increasing and decreasing function 1, and number 2, maxima and minima. Okay, so now I will start with indeterminate. Sorry. In, increasing and decreasing functions. So how to do this kind of problems in the increasing and decreasing functions? You have to follow just 3 steps. Let's say understand with the help of numerical directly without wasting our time. Let's take a sum as x cube 6x square plus 9x plus 15. So you have to follow your 3 steps. Step 1, differentiate. We will get as f dash x, and you will get it 3x square minus 12x plus 9. Okay, and let's simplify this. This will be simplified as taking 3 as common. It will come out to be x minus 1 and x minus 3. Got it? Step 2. Okay, this one was step 1. Now I will show you step 2. Find the value of x by comparing it with 0. What does it mean? F dash x equate it with 0. That means अब ये यहाँ जाएगा, and 3 into x minus 1 into x minus 3 is 0. Okay, so take out the values of x, and that is 1 comma 3 you are getting. Done. Now comes the real step. There's a third step. Always do this step in very cautiously. Single mistake, and MCQ there is no step marks. You will lose all your marks. what is the thing to be done, and that is draw number line. LHS minus infinity. Well, in this sum, no interval is given, but if you are given interval, you will just put the intervals and find it in them only. And what we have got, 1 and 3. So let's put 1 and let's put here 3. Let's put here 2 also. Let's put here 0. Okay. So make a table interval. I'm writing in short as int. Then sign and result. Result bole to whether the given function is increasing or decreasing. If it's increasing or decreasing, in which interval it is. So okay. So now let's take the interval as minus infinity to 1. So let's take a value like 0. Okay, let's take 0 and see, put it here. Put here 0. What will it be? 3 into minus 1, minus 3 into minus 3, it will be 9. So result is positive. Sign is positive, that is plus sign. Wait a second. ठीक है. And so result will be its increasing function in the interval minus 1 infinity to 1. Then we will take the interval as 1 2 3. Here just put the value. We'll take a value, for example, between 1 and 3, take a number called 2. Okay, so after putting it, what you're getting? 2. 2 minus 3 is minus 1, and 2 minus 1 1. So ultimately it is coming out to be negative. So result is decreasing. Finally, in the interval 3 to infinite, put a value. Just take 5, 4, whatever you like, more than 3 till infinity. Take 1000, 1000, 10,000, whatever you wish, and calculate. It's 4 minus 1 and 4 minus 3, it's 3 and 1. So obviously the value is positive, so it's again increasing. Henceforth, this this given polynomial function is increasing in the interval of minus infinity to 1 and 3 to infinity, whereas it's decreasing in the interval of 1 to 3. So I hope you are able to understand this. Let me just summarize the 3 steps again. Step 1, differentiate with, wait, let me write it in text, that is the best thing I can do. So let me write it here only. Summary. So step 1 is differentiate with respect to a given function. To equate f dash x is the function is x with 0. Finally, make a table. Okay, draw a number line and make a table of interval sign and um, result. And result. So, what is somebody first differentiate with respect to the given function, then equate f dash x or f dash y, whatever is the given function with 0, then draw a number line, and on that number line, you have to with the given interval. Okay, here I have to add and take out the values of x. Okay, and taking the number of x, see whether the interval, in which interval it's increasing, decreasing. Okay, and take the answer. That's how simple it is. So this was all about increasing and decreasing function. Now I hope you are able to understand it. Now I will do with maxima and minima. So what is maxima and minima? This is basically the question will come out to be to find the extremes of values. Okay, the extreme of values means find the maximum value and the minimum value. You know how to find that? Obviously from the name you are able to get it that you have to put values in the given polynomial function so that you get it so that you get the maximum and minimum values of it, right? So let's understand this with the sum itself. F of x is equal to 3x cube minus 9x square minus 27x plus 15. Okay, now again you have to follow here 3 steps and you will get the answers very well. So let's take step 1 and then I will write the summary of it. Okay, step 1, find f of x. Guys, keep on making notes as per I'm giving. This will help you out in the exam also. So what will be f dash x? It will be 9x square minus 18x minus 27. You can simplify it more by taking the values. So you can do that in step 2. Again, it's same as increasing function only. Equate f dash x with 0 and find out the value of x. In this case, the value of x coming is -1 and 3. If you calculate yourself, you will get it. You will easily get it. Finally, step 3. Find second derivative. On finding second derivative, what we will get is add in x minus add in. Okay. Now, what will you do? Put these -1 and 3 into this. Okay. So one value it will come as -36 and another will come as 36. Now remember this thing. This is negative, which is a low value. This is positive, which is a high value. But this -36 came due to what? Applying here -1. So this x is equal to -1 will provide the maxima of the main equation. This minimum value of double differentiation, that is -1, will give the maxima for this polynomial equation, and this maxima value will give the minima for this. How? Just put the value f of -1 here. So what will it come? -1 here. So 3 into -1 to the power -1 cube, which is -3, minus 9, because -1 squared is 1, plus 27 plus 15, right? So it will come as 30, comma, and f of sorry, I'm very sorry, I have written there a dash. It's not a dash, it's f of 3 only. Okay, sorry for my mistake. So f of 3 will give you the value as -66. So 3 is giving you the minima and -1 is giving you the maxima. Hence both proved. Okay, we have got maxima and minima. I hope you have got it. And now let's summarize the entire maxima and minima. I'm just writing it in a text format so that you guys can get it. So step 1. Find f dash x, or whatever the function is given. Step 2. Equate this with 0 and find out the values of x. Third and the final step, find the double derivative of the polynomial. Okay, and put the values of x here. Okay, so you have got the values of x here. You will get it negative, positive, whatever, and then put the values minus 1, 3, or whatever it will come, a comma b in it, and find the maxima and minima. Which one will give the maximum value of the polynomial function, and which one will give the minimum value of polynomial function. And with this, guys, good news, we are done with the MTH165 revision, and now you are ready to sit in the MTE. Questions will come very easy, so you all can do it quite well. So that was all. We have completed the entire syllabus. So what we all have studied today, we have studied Maclaurin's theorem. I hope you have taken the screenshot. If not, go back to the video, starting, and take a screenshot of the Maclaurin's theorem, and then go to the Taylor's theorem, and see how I derived the Maclaurin's theorem from there, and see how I derived the equation of e to the power x sin x. Also, guys, there's a homework. Do this positively. Try to find out cos x and tan x values using that, and try to send in the WhatsApp group. If unable, I'll help you out. I'll send you there itself. Okay. And so, using Taylor's theorem, you are able to find out. You just have to put the values of x, and you can find out any sum, any expansion series. Then indeterminate form. So what are the indeterminate forms? They're not meaningless. Just there will be a point where they all you will get the result of it. The forms are 0 by 0, infinity by infinity, and there's 5 others. So how to solve them? You have to do L'Hopital's rule. L'Hopital's rule. You can also call it L'Hopital's rule. What name doesn't matter. What matters is the formula, and that is you have to differentiate the numerator and denominator with respect to the function given in the question. Okay, and you have to apply L'Hopital's rule until and unless the determinate the 0 by 0 and infinity by infinity form abolishes, and you get the right answer. Okay, unless you are able to put limits and get a proper answer. Okay, that's it. So then we moved on to the increasing and decreasing functions. So in increasing and decreasing, we summarized the entire all the numericals into 3 steps. Okay, so let me repeat the steps again. So the first step was find out the differentiation of x and then equate it with 0, and then third step was draw a number line and then find in which interval the sign is positive and negative. The result will be increasing and decreasing accordingly. Then we went on ahead with the maxima and minima, where we also again got 3 steps as it is visible on the screen. Find the differentiation, then equate it with 0, then find double differentiation and put the values of x into the value of double differentiated function. You will get the values, and as per that you will get the maximum and minimum by putting the actual values of by putting the values of x that you have received from single differentiation and equating it 0 into the main polynomial function, and you will get the maxima and minima value of it. So with this we have completed the revision. Thank you guys for patiently watching all the classes, and I hope and all the best, and I hope you all will do very good in the exams. So that was all for the MTE revision. You all can move ahead to your studies. Have a nice day. Thank you.